Hi everyone, today's subject is dithering. So this effect. So it's a pixel effect like the one I put on my sequencer last time. So I know a lot of you were interested in recreating this effect, and last tutorial was centered on the functionality of the sequencer. So today is a separate video just on this effect, how to achieve Bayer matrix dithering, which is this one, and also dithering in a broader sense, so you can get your own effect, your own filters, based on the same principle. First, we need to touch on what is a threshold effect and what is a hard mix. We're going to use this one a lot. Threshold, what is a threshold? For this, we need just an image. Let's put a noise top. So tab to get the OP create dialog. We need a texture, so top, and I just selected noise. And let's put a threshold just after. Sorry for my pronunciation of this, it's like basically one of the worst thing to pronounce just after dithering, which is the topic of today. So it's like I nearly didn't make the tutorial just because of those two words. What is a threshold? It's an effect that enables you to select from an image just the part of an image that's below or above a certain threshold. So here we can see that it's the threshold is just 0.5, and when we adjust it, we just have like an output, a black and white output. Here it's just even transparent and white. So when we put it at even like 0.1, we only have what is below 0.1 luminance of your image. So what's darker than 0.1, 0 being black and 1 being white, this is what you will lose in the threshold. If you adjust it and get it higher, now the transparent part of the image is just what is below 0.789 in luminance. And we're going to use hard mix instead of threshold. So let's put a composite top, and you'll find the one you're familiar with, like multiply, add, overlay, inside, luminance, this type of operation, but here you have a lot of them. And what the one we're going to see today is hard mix, this one. So here we have an error. If I click here, I see error, not enough sources specified. So in order to work, it needs at least one more operator. So let's put a constant. Constant, it's a texture that outputs like a uniform color for every pixel of the operator, of the texture. And when I put it here, the result is all white. So you can see the hard mix operation as being exactly what the threshold is doing. And now the value of our threshold, it's not like the cursor, it's not the slider that was like 0.5 and that we animated. Like let's put it back to 0.5, the threshold one. So now what think of this image as the threshold for the image above. I long click and go right. And now you can see that I can adjust my image, and it makes the same operation. If I put it at 0.5, we should have the same, or maybe just reverse in terms of black and white. 0.5, yeah. And so this is the same. You can see this is the same operation here. You can see the small islands. So basically we just recreated this operator with two operators. So if you feel like you're just wasting your time, just wait a bit, because what's interesting with a hard mix rather than a threshold is that hard mix is doing this operation for each and every pixel of your screen. Think of this texture not as an image. So here, this pixel here is going to set a threshold of 0.49 for this pixel here. So if it's brighter than 0.5, it's going to output here a white pixel, and if it's darker, it's going to output a black pixel. So it's just like a comparator kind of operation. So this is really simple. And right now it's the same, like this is uniform color. So it's exactly the same for every pixel. I think you're going to understand where I'm going with this. If I take, for instance, a ramp is like blending of two colors, and I replace this, so I hover until the connection is yellow and I release. Now you can see that the image is not uniform anymore, and here it's setting like a black threshold here and a white like threshold of 1 here, 0 here, 0.5 here, but it's transitioning. And if I, for instance, decrease the period, you can see the effect. It's getting really interesting. And when it's small enough, from afar, it's kind of recreating the same values as you see here. So you see that it's here and here is just with threshold and hard mix, we are converting a grayscale image to black and white. But with this technique, with the hard mix, we don't lose as much information as with this one. Now, with this, you can imagine like how it's coming. It's just the same principle, but what is different is exactly the matrix used here. So it's not the ramp, it's a bit more complex texture. I wonder what was the best way to provide an image. I wanted it to be like really future proof. So what we are doing is we're going to go into the description of this video. You're going to copy and paste these numbers. So back in Touch Designer, let's create a text dat. Dat is a family of operator that enables you to write text, to do tables, CSV, this kind of stuff, programmation. We just need somewhere to paste the text, so we are selecting text. Now we can directly type in the window. We need to activate the operator. So it's the same way you put your chopped in active mode, is by hitting A or clicking the plus key and paste the numbers. This is like you have all the information for the Bayer matrix here. We just need to transform it from this text into an image. For Touch Designer, it's not a big deal because Touch Designer just sees everything just as data, and then it's for you to tell this is an image, this is a sound. So let's transform this into a table with a convert dat. Now it just created one row per row of our text here, and we also need to say each different number is like a different cell. So split cells at just put a space, do not leave like just empty, put a space, and now every time it will see a space in this text, it will split the cells, and you have a 8 by 8, so 0 to 7, 0 to 7, 8 by 8 table. Now we can't directly transform this into a top, so we'll just create a chop. So I just drag a connection from the output of the convert, then select dat to, so from a dat to a chop, and then for the output I say I want like channel per row. Okay, I want a channel for each row. Yes. First row is values. Yes. But first column is name. No, first column is still values. So you need to select first column is value. If you don't do that, you're going to lose one row. Okay, perfect. And then we can use this and transform it into a texture. Chop to. And we have our Bayer matrix. It's really blurry because it's interpolating between the values. as it's just like 8 by 8 pixels. So go to common and viewer smoothness nearest pixel. And this is basically the matrix we're going to hard mix with our image. So what's it doing? It's taking, for instance, this here, 1, it's making it into a channel and it's saying this is 1, and then it's putting it into an image and saying, oh, now it's an image, 1 means white, so now this is white. So to make things easier, we're going to set a constant that will help us say how many times we want to repeat this 8 pixels texture, because if we have a 128, a 256 white texture, we need this texture to be more precise, like to have more pixels. So I put just a constant and a null. Here let's make an image 128 by 128. We're sticking to powers of 2 because it will be simpler. And I say I want, so I want it to be 128, so 16 times 8 is going to be 128. First, we need to fit this image to be bigger, to be 128 by 128. And actually, we won't directly put 128, go with nearest pixels here. We won't directly put 128 here. We just use this constant to say we want it to be 16 times 8. 16 times 8. So 16 is operator null 1 chan 1, and we just multiply it by the number of pixels we have here. We could also, if we want it to be really responsive to this texture, we could say to operator chop to 1 dot width, which is going to be the same. And now we work with squares times width also here. So right now it's exactly the same as saying 16 by 8, but if this image changes resolution or we want to have more copies of it, we can directly put it and it's responsive. Okay, now it's 128 pixels, but it's still this 8 like pixels here, but these pixels are now made of 16 pixels by 16 pixels. We need to scale it down. So let's use a transform and scale it down 16th time. So here in scale, I just activate and reference the value, but I will put 1 over 16, so 1 over operator null 1 chan 1. Okay, this is great. It's exactly now 1 pixel per pixel. But I don't want to have all these black borders. I want to have I want to fill my screen. If I want to fill my screen, I can use this tile tab and extend my image. So I have different parameters. So I have different parameters to extend my image. When it's scaled down so much that it just creates these borders, I say repeat, and now it fills my screen. It's just tiling the image to fill the screen. And now my image is 128 by 128, and there's 1 pixel for each pixel of the texture. So this is perfect. Now let's take just a noise with a high resolution that you can later change for what you want. So let's go with 1280 by 1280. Nice. And let's scale it to the same texture. So here, let's go with exactly the same, fit, copy and paste, and put this in this place. It's really important to have the same resolution between the texture here and the texture you are combining it with. Even if you want to have like a higher resolution one, your webcam, typography, anything, for the effect to properly work, you need to have like the same resolution. Let's go with bigger here, harmonics down, yeah, it's a bit smoother. And now we can safely put a composite top and combine the two images, use hard mix, and it works. In the comp, the command page of the comp, say here's pixel, and this is the effect. So you see the effect is really straightforward. Once you just make sure that your image are the same size and it ties nicely, it's just really plug and play. You're going to be frustrated if you don't set up properly before, because then you see like the pixels mismatch or are not matching properly. That's why I prefer to stick to square resolution and maybe crop after if I need different resolution, because it can really be messy to set up otherwise. So if we do not 16 but 32 now, so okay, and yeah, just doesn't work well because of this, because like it's not 1-to-1 pixel. So here it does like some weird stretching, but if I see here, it's still like 1-to-1 pixels. They're still square. Okay, and then you can animate your noise. Oh, this is not my noise. This transform. Go with the AppsTime.seconds usual. And yeah, now you have a shader, like you have your dithering shader. So now that you understand how this basic Bayer matrix works, it's up to you to find the perfect texture or different texture to shade your image. So for instance, we could use another noise. So if we take this noise, duplicate it, and have a really small period like this, we can combine the two with a composite top into hard mix, and the result is this, like the same principle, just with noise. Basically any image will work as long as when you look it from far away it's gray, it's a kind of middle gray, and if it has some gray, like fairly linear gray values. You could also use a ramp as we saw earlier, but let's make it with a higher resolution, 1280 by 1280. Small period. This, if I look at this from far away, it's kind of gray. And here the interpolation is linear. So here it also works. So now you can really be creative with different picture. You could use really anything. So I hope you understand now how dithering works, how you can use like a Bayer matrix or any type of diffusion matrix, or even textures to shade your images. The file, like this file, will be available on the Patreon. It's the same file that you see here. There's no added value. So if you follow the tutorial, you will see this. And you can also join the Discord server, which is free and on which you can participate to challenges and get help on your patches. There's a help me channel on which you can request assistance. So I will do my best to help you, but the other members are often faster to answer. So I hope you like this tutorial, and don't hesitate to suggest if you see something that I'm doing you would like to learn. And see you in the next one.